Hello students, in this video we will solve quadratic equations using the zero-factor property as a result of factoring. Starting with the definition of quadratic equation. A quadratic equation in x here can be written in the form ax squared plus bx plus c is equal to 0, where a, b, and c represent real numbers. And a cannot be 0, because if it were 0, then this first term would be 0, and there would not be an x squared term. For it to be a quadratic equation, it must have an x squared term. The given form is standard form, and that occurs when every term is on one side set equal to 0 on the other, and our terms are written in decreasing degree order. The zero-factor property is really the only property that we need in order to solve these quadratic equations by factoring, and it's pretty straightforward. If the product of two factors is equal to 0, then the first factor a is equal to 0, or the second is equal to 0, or both. For example, 4 times 0 is 0, and 0 times 4 is 0, and 0 times 0 is 0. So it doesn't matter which factor is 0, our end result product is 0. And if both factors are 0, of course the product will be 0. Now we're ready. Here we go. In example 1, we will solve each equation. Now in part A, we first want to add 6 to each side so that we can write this equation in standard form. And next we factor it. Here we've got a trinomial with a leading coefficient 1. Therefore, we know that the first terms must both be x. Now our only question is, what are factors of 6 that sum to -5? We've got a positive product, yet a negative sum. And so we know to use negative factors, -3 and -2. Notice your inner and outer products total -5x. Now we use that zero-factor property. If the product x minus 3 times x minus 2 is equal to 0, then x minus 3 is 0, or x minus 2 is 0, or both. And now solve each linear piece. X is equal to 3, or x is equal to 2. And we would say then that our solution set includes the numbers 2 and 3. And we can write those in either order as we're listing them as elements of a set. Remember that you can always check your answers to an equation by simply substituting them back into the original equation and showing that they check, they work, they satisfy that original equation. Part B, it's already in standard form, and here we have a difference of squares, which factors 7x plus 3 times 7x minus 3. Zero-factor property, 7x plus 3 is equal to 0, or 7x minus 3 is equal to 0. Subtract 3, divide by 7. X is -3/7. Solving our other little linear equation here, add 3, divide by 7, x is +3/7 in our solution set. Then includes -3/7 and +3/7. Notice here that a quadratic equation can have up to 2 solutions. So when you see a second degree equation in there, you can expect as many as 2 solutions. They don't always have 2 solutions, but they can have as many as 2 solutions. Part C. Let's write this equation in standard form by adding 64 to each side. Now we factor. Well, this looks like it might be a perfect square trinomial, and I think it's going to factor x minus 8 times x minus 8. Let's check that out. X squared, last 64, inner and outer products sum to negative 16x. Yes, so see how we've got repeated factors this time? And as we use our zero-factor property, we're going to see then repeated solutions, okay? Because we obtain x equal 8 for both of these. So here's the case where we've got a quadratic equation. It can have as many as 2 solutions, but this one only has 1. Okay, the solution set includes the number 8. You don't have to write 8 twice. That would be redundant. We do, however, say that 8 is a solution of multiplicity 2, meaning that it's a repeated solution 2 times. But for now, just say the solution set is 8. Let's see, part D, that looks like it might be a perfect square trinomial as well, because the first term is a perfect square, our last term is a perfect square, and let's see if our middle term matches up here. So the first factorization that we should try is 3t minus 5 times itself. And just check your inner and outer products, which are both minus 15t, which total together the minus 30t. So again, we've got another perfect square trinomial, and we know that as we use our zero-factor property, that because these factors are repeated, that the solutions or zeros are going to be repeated as well. As we add 5 and divide by 3, to obtain t is equal to 5/3 in both cases. Solution set, 5/3, and this is also a solution of multiplicity 2. And again, you can check your answers for all of these. In fact, let's check that one. What do you say? Let's check t equal 5/3. Now you always want to check in your original equation. 9 times 5/3 squared minus 30 times 5/3 plus 25, is that equal to 0? Okay, there is our question. Well, 5/3 squared is 25/9. Let's see, 30 divided by 3 is 10, and 10 times 5 is 50. Plus 25, is that indeed equal to 0? In other words, is 25 minus 50 plus 25 equal to 0? Absolutely. 5/3 is said to satisfy this equation, and therefore it is indeed a solution. Well, let's continue to part E. Now notice that this is a third degree equation, also called a cubic equation, and it can have as many as 3 solutions. And we're going to find those by factoring, starting with a greatest common factor, 3x times x squared minus 9. And let's continue to factor. X squared minus 9 is a perfect square, which factors x plus 3 times x minus 3. Hard part's over with. Now we use our zero-factor property and set each factor equal to 0. So 3x is equal to 0, or x plus 3 is equal to 0, or x minus 3 is equal to 0. Dividing by 3, we obtain x equals 0. Subtract 3 to obtain x equal negative 3, and add 3 to obtain x equal positive 3. So again, this was a third degree cubic equation, and it can have as many as 3 solutions, and here they are. We say that our solution set includes -3, 0, and 3. And again, you can write those elements of that set in any order that you want. I just have a habit of writing them smallest to largest. Now, our last equation, this is going to need some simplifying first. So let's begin by distributing and write 4x squared minus 9x. And let's multiply x minus 2 times itself. Okay, so here we go. X times x is x squared. Our inner and outer products will both be minus 2x. They combine to minus 4x. And lastly, -2 times -2 is positive 4. Now, if you need to step out to the side and write x minus 2 times itself, and use your FOIL method, okay, go ahead, that's all right. You'll obtain x squared minus 4x plus 4. Now, let's see, we've also got this plus 24, don't forget it. Let's see, I'm going to, let's go ahead and move terms to the left-hand side. I think we can handle that right now. So let's subtract x squared from each side. 4x squared minus x squared is 3x squared. And we just took care of those terms. -9x plus 4x is -5x. So we just took care of our x terms. Now, on the right-hand side, 4 and 24 is 28. And when we subtract it over, that becomes a minus 28. Set equal to 0. So here we've got our equation in standard form. Let's factor. Trial and error is a good option here because we know that our first terms are 3x and x. Now it's just a matter of finding our appropriate factors of -28. And I'm going to opt for working with 7 and 4. And if we place a 7 in our first parenthesis and a 4 in the second one, then we can see that an inner product will contain 7x, and we've got an outer product of 12x, and if the 12 is negative with the coefficient 7 positive, we can obtain -5x as the sum of our inner and outer products. And so let's make sure that our inner product is positive by placing a plus up front, and that our outer product is negative by putting a minus sign in that second parenthesis. All right, hard work's over with. ZeroFactor property. So let me just come this way here. 3x plus 7 is 0, or x minus 4 is 0. Subtract 7, divide by 3, x is -7/3, or x equal 4. And we would say that our solution set then contains the number -7/3 along with 4. In this video, we have solved quadratic equations. We even threw in a cubic equation, didn't we? But our method of choice was factoring. So make sure that you always write these equations in standard form. Set them equal to 0 so that we can then use that ZeroFactor property. Good luck with those.